Very good morning, students. Welcome to today online classes. Today we are going to discuss one of the important topic. Already you discussed those topic in your primary sections about shapes, lines, angles. So the topic we are going to discuss is understanding quadrilateral about the introduction. It is the third chapter in your textbooks. Okay. This concept is based on the conversation of two friends about polygon. So who are they friends? Yeah, Johnny and Jenny. The two characters going to explain about polygons. Johnny and Jenny are two close friends. They went to the school to discuss about classes of polygon. Do you know polygon? Jenny? Polygon? No, I don't have any idea about polygon. So let me go to the racket. Okay, look at this figure. So it's a normal figure where we find in everywhere. So it contains lot of polygon. So the green mark is given over the shape of the polygons, and like this pictures of polygons we can get everywhere in your life. Even in your home, your office, you can get a polygon of shapes. That polygon. So a polygon is any two-dimensional shape formed with straight lines. Okay, Jenny, do you understand that? Yeah, okay, I understood that, Johnny. Okay, the conversation between the polygons. So we don't know the polygons, but it's line segments. Three-sider. It's a four-sider. This one five-sider. This one will be a six-sider. All the figure made with two dimensions, and it's made by closed figure also. Hello, I'm triangle. Hi, I'm a quadrilateral. Hi, I'm pentagon. Hello, I am hexagon. So not only these figures, we have few more steps of figures, three-sider, four-sider. The figure will be extended to that based on number of vertices. It will be classified into different types, and the sample figure also will given here. The number of vertices three-sided as the given before as triangle. This figure is given here. Four-sided vertices is given as a quadrilateral. The figure also given the right side. And five-sided figure is called pentagon. The shape of the figure is represented. Six-sided figure is called hexagon. The shape also given. And seven-sided we call as heptagon. Eight-sided we call octagon. Nine-sided we can call nonagon. And 10-sided we can call decagon. And the n-sided of figure, because some figures we doesn't know the number of sides. Like 11 sides, 2, 12, 13, 14, 15, it go till infinite. So if you take any number, so the number of sides will be into the format of n again. So we have a conclusion over circle. Circle also called as polygon if it's made by line segment. A simple closed curve made up of only line segment is called polygon. This is the basic simple definition of polygon. Okay, what is polygon? We are discussing about polygon and quadrilateral, sides and line. So is any figure all non-polygon figures are there? Absolutely, there is some non-polygon figures also there. The yellow color figure and blue color, red color and remaining two colors figures also given, not only made by line segment. These figures made by curved line also. So the red color circle is made with curved line. Suppose the circle is have infinite number of small line segment. If made with the small line segment, that also comes under polygon. If is it not, then it will come as non-polygons. Hello, I am not. I am too. I am also not. I am also not. I am also not. So we all are not in the figure of non-polygons. We are in the figure of non-polygons. We are not comes under the polygon figure. And finally, again Jenny, John. So these figures also not a polygon. Am I right? Because it's not made by line segment only, but it's not a closed one. It not proper endpoint is there. Yes, dear, you are correct. You are always right. These figures are not a polygon. So polygon have a different shape of titles. We are going to substitute over here. Polygon, concave polygon, convex polygon, simple closed figure, regular figure, angles, opposite side, parallel side, angle sum property, quadrilateral, perpendicular, complementary, supplementary, transversal, rectangle, parallelogram, exterior angle, square, measures, side, kite, trapezium, corresponding, pentagon, triangle, adjacents, and few more steps. These all concepts will comes under the polygon topics. We are going to discuss one after one. What is closed curve and open curve? Many of you have a confused about closed curve and open curve. So closed curve is a figure in a plane with no endpoints. It completely enclosed an area. So it's a closed figure, it has no endpoint. The picture is clearly explaining over. The two pictures also made with a line segment, but it's a closed figure, it completely encloses by area. So but what about the open curve? Open curve is a figure in a place with endpoint. It have an endpoint. Yes, these two figures have open curve because it have an endpoint and it is not enclosed by any area also. It's just open. This is the simple definition of closed curve and open curve. I hope you understand what is closed curve and open curve by this example. So closed curve figures have interior and exterior options. So for example, so I am the inside the house, some of you will outside the house, some of you standing on the house. So these are the three basic example will be given. So for your better understanding, I am ready to produce some diagrams which give you explanations of interior and exterior of a closed figure in very detail. The first figure it shows this closed figure. It's a closed curve. It have the interior parts are shaded. The second figure the same closed curve but the exterior parts are shaded. Some points lies on the curve is called non-exterior, non-interior. It's called on the figure. So every figure have interior side and exterior sides too. And the next topic we are going to discuss is diagonal in polygons. Is polygon have a diagonals? Is that so? Okay, if so, what is the definition of the diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. What is meant by non-consecutives? Which is not next to us. It is just after us. Next to the content we are not supposed to add. For example, if you explain take the example of this two figure, the lines which is drawn over inside the figure is called diagonal of a polygon. Could you understand the concept? If you not, I am ready to give few more examples to make you people to understand about the diagonal of a polygon. It's a very simple concept. Look the figure of first two. The first figure is represented as A, E, D, C, B, or you may call as A, B, C, D, E. The second figure is represented A, E, F, B, D, C. So that is some lines are drawn inside the figure. If you look at the first figure, AC is the diagonal. Similarly, we can draw AD also diagonal. If you look at the second figure, AD and BC are the diagonals. Then what about CE and DF? That are called perpendicular line, like called as altitudes. This all comes under diagonals. So these are the best examples. So ready? Okay students. Now I am going to give you few examples for your representations. You have to find out the name and name the polygon in the given figure. The first figure is PQRS, where PR and SQ are joined. You have to find out the diagonal of the polygon in this figure. Yes, PR and SQ are the diagonals. There is two diagonals in this figure. If you come to the second figure, ABCDE, AC, AD, BE, BD and EC are the five diagonals are drawn over here. So the next second figure is representing five diagonals. The third figure also LM and K. So KM and LN are the two diagonals are given. So look at that. First two figures, all the diagonals are lies inside the figure. But second, third figure, the diagonal, one of the diagonal is lies outside. So we should be very careful when we are working such kind of problems and getting to the diagonals. Okay students, do you understand the concept of diagonals? Next, based on diagonals, the polygons are divided into two types. The first one is concave polygon, second one is convex polygon. So what is the difference between concave and convex polygon? Looking at the figure, the first two figures of concave polygon is represented here. Do you find any idea about the concave polygon? Yes, we don't have all the diagonals inside the polygon, because as we explained the previous slide, previous pictures, so the third figure have one of the diagonals lies outside. So such kind of figures are called comes under concave polygon. Now you can guess idea about what is convex polygon. Yes, you are right. Now the four figures are given in front of you. All the four figures we have the diagonals or lies inside. So we have all the diagonals inside the polygon. These are the basic differentiation between concave and convex. Concave means all the diagonals are we're not sure about lies inside, some may in outside, but convex figures all the diagonals should be lie inside the figure of the given polygons. I hope you understand this. Okay. Jenny, listen, four-sided polygon called quadrilateral. What is meant by this? Do you understand? Okay Jenny, I got it. Okay Johnny, it's a four-sided polygon is called quadrilateral means. Okay, let me have some example please. Yes, of course Jenny, you will get some example. The first figure of name of square, it have four sides. The second figure is name of trapezium, four sides. This is parallelogram, four sides. Rectangle, four sides. This also comes under parallelogram, four sides. So now given all the pictures, it comes under the topic of quadrilateral, because all the figure have sides as four. Yes, four-sided polygon is called quadrilateral. Okay, fine. Now, do you have any other example apart from these common type of figures as we already learned in our primary sections? If I draw any figure like in the shape of four-sided, it will be a quadrilateral. Yes, of course, you can look into the figure of examples. So now the five pictures are represented here. All the five pictures have the sides of 4. Do you think it's a quadrilateral? Yes, of course, it is a quadrilateral. It's a type of quadrilateral too, because it has 4 sides. Any figure having the sides is of 4 is called quadrilateral. So now I hope you understand what is the basic note of quadrilateral. It's nothing but a polygon made with only 4 line segment is called quadrilateral. Okay, I hope you know that these are the things we have discussed over, and the polygon and exterior angle, angle sum property, convex, concave. We are going one by one topic to get you people to get closer about the concepts, to get to know the quadrilateral very detailedly and clearly. Okay, do you think and do you guess any idea about the next one? Yes, there is some will be regular, some will be irregular. So regular and irregular polygon only we are going to discuss. Look at the two examples. The first example, regular polygons. So it's a triangle. A regular polygon is both equal angular or equilateral. So all the sides and angles should be same. If you check out the first figure, all the sides and angles of the first figures are same. So which is representing called as a regular polygon. So the second figure, it will be a right angle triangle, rectangle and few more figures. You can take a look over, the sides may be in different size and angle may be also different. It's representing the second figure. So the polygons are not a regular. So regular figure mean all the angle and side should be equal in measure. So the square is a regular polygon, but a rectangle is not. Are you sure about it? Here note it very clearly. This indication of these two numbers is representing different sides. If you mention only one line, that is the same lines. If you mention the two lines, so that is different from the one line. So we should be very careful about to work out the concept of regular polygon and irregular polygon. So as we know the definition, the first one will be regular polygon, equilateral triangle. The second one will be called as square. The third one will be a regular pentagon. The fourth one will be regular hexagon. So this is what given. The square is a regular polygon, but rectangle is not. Equilateral triangle is comes under that. Wow, a butterfly is flying. It's a origami. Yeah, good. The next, Johnny and Jenny, welcome back to the class. Are you in class? Yes, I'm happy for you. Jenny, do you know? Now you understood all the kinds of quadrilateral. I think you got it, yes? Yes, Johnny, I got it. Okay, Jenny, let me go for the next topic of quadrilateral of interior and exterior angle. Each and every figure have interior angle also exterior angle. The first picture is clearly explained how the exterior angle will be derived. The angle which is given outside of the figure by extending the line of borders edges is called exterior angle. If an angle have interior of any two edges is called interior angles. These are the simple explanations to know about. When you discuss about the angle, I have a doubt about one thing, Jenny. Do you remember angle sum property of triangle, Johnny? I have a doubt. I'm thinking. Yes, the sum of the measure of three angles of a triangle is 180 degree. Also, we will know about angle sum property of quadrilateral. Is it so? I'm exciting to listen. Angle sum property. Okay, let me take this example of activity to work out to get to know about angle sum property. Take any quadrilateral, says A, B, C, D, divided into two triangles. By drawing the diagonals, you can get 6 angles as given in the pictures. 1, 2, 3, 4, 5 and 6. You can represent these numbers of angles in anywhere as your convenience. It's not necessary you have to represent like the same. Use the angle sum property of a triangle and argue how the sum of the measures of A, angle B, angle C and angle D amounts to 180 plus 180 is equal to 360. Any guess? Yes. Angle sum property of a triangle is represents 180 degree. Here two triangles are given by dividing the figure by diagonals, which is nothing but 180 plus 180, 360. Take the 4 concurrent cardboard copies of any quadrilateral ABCD with angles as shown in the figure. Arrange the copies as shown in the figure where angles 1 and 2 are meet in the point as given in the point 3.5 the first one. So for doing this, you have to turn the match of appropriate corners so they can fix it. So if you have any doubt, you can refer the figure to fix it over here. What we can say about the sum of angles 1 to 2, 3 and 4 in the given figure now? We denote the angle of 1 and 2 and 3 or 4 of the corresponding measures of angle of 1, measures of 2, measures of 3 and go on. The sum of the measures of 4 angles of a quadrilateral is 360 degree. So the angle sum property of interior angle of a quadrilateral is 360 degree. You may arrive at this result in several other ways too. So I hope you understand how to represent the angle sum property of the given figure. I expecting you people to work out like the same in angle sum property and get to know the solution of the given problem. If you know this angle sum property may applicable for many of the problems, that's also we are going to discuss in further classes. We can find the unknown angles in a quadrilateral from angle sum properties. For example, in the first figure having the three sides. I hope you know that the name is triangle. Angle sum property of triangle is 180 degree. The second figure is representing by the four sides, that is quadrilateral. It is divided by the diagonal into two triangles. Each triangle have 180 degree as measures. So 180 plus 180, which is called, you will get the 2 into 180. You will get the answer for that, 360. The third figure is representing the five sides. I hope you know that is pentagon. It have two diagonals. So now 3 into 180. So 180, 180, 180. 3 times triangle is there. So you have to multiple and get the resultant over. And the fourth figure also, it have the six-sided polygon. You know that hexagon. Hexagon, it's divided into 3 diagonals. The 3 diagonals is dividing into 4 triangles. Each triangle angle sum property is 180. So 4 into 180 is representing as, you will get the solution for that. But how to identify? Without doing this, you have to identify using the formula to get to know the angle sum property of a given figure, either triangle, quadrilateral, pentagon, hexagon, heptagon, nonagon, octagon. It go on infinite numbers. Suppose a figure have 28 sides. How to find out interior angle? So that is a very simple formula. Angle sum is equal to n minus 2 into 180 degree. Here n is represent to number of sides. Now you can come for the picture. The second one, quadrilateral, is a 4-sided polygon. So n is equal to 4. 4 minus 2 into 180 is 2 into 180. The third figure, 5 minus 2 into 180, that will be 3 into 180. The fourth figure, 6 minus 2 is equal to 180, 4 into 180. Suppose your figure have 20 sides. How could you represent? 20 minus 2 into 180, which is 18 into 180. This is a simple way of solution to get to know the interior angle. Now, okay, I hope you understand the topic. So whatever discussed, based on that I am given some exercise problems to you to get to know the solutions. So the first exercise, some figures shapes are given. We have to classify each of the bases in the form of simple curve, simple closed curve, polygon, convex polygon and concave polygon. The things already we discussed in the class, I explained you in the previous views. Please check it over. If you have a doubt, just give the answer for the correct representative. The second one, how many diagonals does each of the following have? Convex quadrilateral, concave quadrilateral, regular hexagon, triangle. I hope you know that how to find out how to draw a diagonal in a given figure. You have to draw according to that non-consecutive sides, and you have to find out how many diagonals are given, and you have to get to know the solution for the given problem. And here regular hexagon is given. Regular mean all the sides and angles are equal. Please listen very carefully to work out the problem. Third one, what is the sum, the measures of the given? So they also solve the problems in the questions. Now I understand everything, Johnny. Very thank you. My pleasure, Johnny. Thank you, children. We discuss the next classes. Thank you.